12.5 is expected value. So looking at using probability to help us find what an expected value might be coming out of a situation. Okay, and I'll explain it here in a few, but let's look at this problem to get us started. A company has 20 employees whose hourly wages are shown in the bar graph. And our first question, an employee is chosen at random. What is the probability that his or her hourly wage is $12 or $25 or $50? So, thoughts on finding the probability that an employee's hourly wage is $12? Take a peek at your chart.
13.
We have employee hourly wages. Options down at the bottom are 12, 25, and 50, which are the three questions we're asking. Along the left is number of employees. How do you think we're going to find the probability that the hourly wage for an employee is $12? We'll start with that question, then we have the other two questions to do too. What? Not 12. And yes, we're going to add something up. I don't know if you have the right things though yet, but what do we know about the $12 hourly wage?
13 of them have it.
She says 13 of them have it.
It's too far away to be 13.
It's on the paper right in front on your desk too.
I know, but it says 14.
I would have said it's 14 personally. You think it's 13?
Yeah. I think if it was...
That doesn't equal 20 unless the 50s.
Yeah, I don't know what that means to me anything.
I personally, so I looked at this as being, and I'll put it down here, that there's 14 people earning $12. And Olivia has a point. We're supposed to have how many employees? We're supposed to have 20 employees. So let's see if we can make this happen. How many people definitely earn $25?
5.
That's 5. We don't have to argue about that one, right? What about 50? What's that look like to you?
Oh.
See, and that,
Yeah, I think too.
I would have said 1. Now, if you're seeing 2 there and 13 on the other one, it still adds up to be 20. What I think, yeah, I have 14, 5, and 1 on mine. I don't know. Because I guess my thing is the halfway point here, like wherever that halfway point is, would be 2.5. Because half of 5 is 2.5. And so if that's the case, I don't feel like this way down here can be 2. I feel like it has to be 1. Personal opinion, but so I'm going to use the numbers. There's 14, 5, and 1. And 14, 5, and 1 does equal the fact that there are 20 employees, which is what we are told in the stem of the problem. So what's the probability that one of the employees earns $12? No. How many do we think earn $12? Out of 20. So I would say 14 out of 20. What do we know about 14 out of 20? 7/10. I guess I have mine as a decimal here. You could have as a fraction, just the same. Okay, let's look at the probability of an employee earning $25. What would you say about the probability of an employee earning $25?
5 out of 20.
5 out of 20. What do we know about 5 out of 20? 1/4, which as a decimal is 0.25. And what about the probability of an employee earning a $50 wage? 1 out of 20, which is 0.05. I think I'd be kind of salty if there's an employee earning $50. $50 hourly wage here.
Look, you know,
Whew.
that's bank right there.
It is, but man, if you're only earning 12 or 25, you know.
You're getting gypped.
Okay. Now, so right there, we've done our base work. We know the probability for earning $12, $25, or $50. Question B. Ask about the mean hourly wage.
Add them up and divide by 3.
Partially right.
Would you divide by 8? 4?
What'd you say?
So would you divide by 20?
There's 20 employees. Now, when we add them up,
12, 25, and 50.
okay, how many 12s are there really, though?
14.
There's 14 12s.
So 14 plus, 12 plus 12.
We could do 12 plus 12 plus 12, 14 times, or what's the shortcut of adding 14 12s? 14 times 12. So we can do 14 12s, 14 times 12. How many 25s? 5 25s and 150. Because if we're trying to find the average hourly wage, we've got to take into account that there's more employees that get the $12. Okay, so that's going to pull down the average hourly wage. So, okay, I'm going to do the $12 times 14 plus the $25 times 5 plus the $50. You can say times 1 if you just want to, you know, be consistent in your setup. And that's technically how many different numbers are we adding? That is 20 numbers. Okay? So, do some math. I know I'm going to be doing something divided by 20. What'd you say for the top? I don't agree with 318. Yeah, I didn't agree with 278. I like 343 according to my notes. Did all the right buttons on the calculator, right? Okay, so it should be adding up to 343. You divide that by 20 and that puts us at what? $17.15, which is $17.15. Now think about it. Does that make sense? You've got, what, over half your employees, almost 3/4 of your employees earn $12. And then you've got 5 employees at 25 and an employee at 50. So yeah, it's going to be down below 25. It's going to be closer to the $12 mark, right? Okay. Now, with that in mind, C asked us a question to think about, and I've kind of already started to talk about it. Is the mean a good description of the typical hourly wage at this company? $17.15 what? It falls between 12 and 25, which is where everybody but one is, right? And $17.15, what's it closer to? It's closer to 12, and more people earn $12.25. Okay, so I would say that, yes, it is. Okay, it is a good description. So, I'm just going to say yes. Mean is a good description. I'm going to say since it is between $12 and $25, but closer to 12. So between $12 and $25, but closer to $12. Okay, so yes, this mean is a good description since it is between $12 and $25, but closer to the 12. Okay. Now, that leads us into expected value. Okay, we kind of, by how we found this mean, kind of demonstrates how we're going to think about finding expected value here. Expected value is the average outcome that will occur with many trials of an experiment. It's the sum of the value of each outcome multiplied by the probability of each outcome. Okay, we kind of did that with mean, except it wasn't multiplying by probability. It was multiplying, we were using it to find the mean. But that's kind of going to be the setup that we're looking at. So expected value, you're going to be looking at each outcome multiplied by the probability that that outcome occurs. Okay, so let's go and look at a problem here of what we could use here. Okay, so in this first example, the table shows data on sales in 1 month for each item on a restaurant menu. To estimate future profits, the owner evaluates the average profit from each meal. So basically, the owner's trying to evaluate their menu and decide, do they have a good menu? Do they need to change things up? And if you're a restaurant owner, you're looking for what's your best profit, right? How can you earn your best profit? So check out your table. You got 4 meals: stew, soup, lasagna, and chili. It shows the profit per serving. So each time someone orders stew, the restaurant gets 34 cents. Each time someone orders soup, the restaurant gets 41 cents. Lasagna is 64 cents and chili is 73 cents. And then it also talks about the percent sold. So in reference to their menu, 12% of what they sell is stew. Up to 36% of what they sell is chili. Now, this says, based on the data, what is the average profit that the owner can expect to make from each meal? So based on how much the owner makes off of each meal, and based on the probability that the meal is sold. Okay, so what percent of the time is that meal sold? So this is where we're going to look at, as it stated up in expected value, the value of each outcome times the probability it will happen. Okay, I'm going to use E, just because that's what you often see. E to stand for, we're trying to find expected value. Okay, what do you know about stew? If someone buys stew, the restaurant's going to make 34 cents. How often do people buy stew? What's the probability someone's going to buy stew? 12% of the time, right? So we're going to start 34 cents, which is 0.34, times the probability it will happen, which is 12%. I'm going to use 0.12. So that's stew. Plus, what about soup? Every time someone buys soup, the restaurant makes 41 cents. What's the chance someone's going to buy soup? 7%. So we're going to multiply by 7%. You can use fraction form or decimal form. I'm going decimal form because that's going to be easier for the calculator, and that is 0.07. Plus, next meal, lasagna. The restaurant's going to earn 64 cents. How often are people buy? What's the chance someone buys lasagna? 45% of the time. So there's your lasagna. And plus?
73 cents. And then 36.
Okay. Every time someone buys chili, the restaurant's earning 73 cents. And there's a 36% chance that someone's going to buy chili. Okay. By putting this all together, this is going to find on the expected value, the average expected value they can make by selling one meal. Okay. mean, we could go through and write down all 4 pieces and then add them, but personally, can't you just put it in your calculator all as one? And that's what I have on my paper. What's the calculator give you when you multiply these 4 and then add them all up?
Is it still a decimal?
What?
Do you have a first number or is it 0?
Like 0 point? Yes.
0.620.
Uh-huh. Is that what you got? Okay. Hopefully your calculator should be saying 0.6203. Now keep in mind, this is the average amount the restaurant's going to make per meal, based on how much they make for each individual meal and the percent of time that each of those specific meals is sold. Now, make this money for me. So this is how many cents? If we do 2 decimal places, this is 62 cents. And so what this is saying is that this is, the restaurant's going to make, on average, 62 cents a meal they sell. What'd you say? It is not very much. I question if that's reality. I don't know. You know, sometimes I feel like our problems definitely reflect reality. This one, I feel like, how's a restaurant going to stay in business? But granted, that's just the meal. What about the appetizers, the drinks, the desserts, I have no idea. Again, I don't know if how accurate this is or not. But that's the idea, They're not going to make as much as 73 cents a meal because they're not selling chili every time, right? But because they sell lasagna and chili a lot more, it's going to, they're going to make more than what they do with the soup and the stew. Now, so on average, the restaurant makes 62 cents per meal. Okay? B wants to know, what is the expected profit for the next 200 meals ordered? How are we going to find that?
You would times 0.62 times 200.
You would? Now, I was going to be a little more specific, and I was going to use that value right there, just because that was the value before we rounded. Okay? And it's not to be that far off, but it's 62 cents a meal, or the 0.6203, times the next 200 meals. So what is 0.6203 times 200? What was it? Okay. And that would be $124.06. Okay. I do agree. There's got to be more to that profit somehow. That doesn't seem quite right. Or maybe this restaurant owner is not in it for the profit. So, okay, C. Okay, we're just going to have to think logically here. What would happen to the expected value if fewer people ordered chili and more people ordered stew? And why would it go down? Yeah. Okay. Overall, your expected value is going to decrease because when you've got people buying chili, the restaurant's earning more money, right? If you've got less people buying chili and more people buying stew, the restaurant doesn't earn as much, do they? Okay. So it would decrease since chili makes a higher profit, but fewer people would be ordering it. That's how I have it written in my notes. It would decrease since fewer people are ordering chili. And chili makes a higher profit. Okay. And I think that's logical, yes. Okay. Okay, D. Suppose the restaurant's profit on an order of stew increased by 5 cents, and the profit on an order of chili decreased by 5 cents. How would these changes affect the expected profit per meal? What?
Would it still be decreasing?
It would. Do you know why?
Because it's still not as much as the chili unit.
Okay. You're offsetting 5 cents both ways, right? But what's the catch? How often is stew sold? 12%. So while you're increasing stew by 5 cents, it's only selling 12% of the time. If you're decreasing chili by 5 cents, okay, but that sells a lot more, doesn't it? That sells 3 times as much because that's selling 36% of the time. Okay, so it would still go down. Does that make sense? Okay, and I would say if you don't believe me, go back and redo Part A with those different numbers and see what happens. Okay, you could go back and redo Part A and decrease that by 5 cents, increase that by 5 cents, and it wouldn't be a ton, but it would be a little bit. Okay. So on mine, I have the expected profit would decrease. More chili is sold, so an equal increase in stew would not be enough to offset chili. I'm going to say it would decrease. More chili is sold. So how do I want to say this to be short? More chili is sold, so an equal increase in stew. Yeah, I don't have a short way to say it. More chili is sold, so the equal increase in stew is not enough to offset the chili. Trying to short it up, but I just couldn't get it short enough for my taste. So I went with what's there. So the expected profit would decrease. More chili is sold, so the equal increase in stew is not enough to offset the chili. Now, it'd be a different situation if we sold equal amounts of stew and chili, right? Then we could talk differently. Okay, so you're seeing a little bit about the basics of how expected profit works, right? Or expected value in general. Okay, you're taking what you could get out of something times the probability that it would happen. Okay, let's go look at some other scenarios. Let's look at this one. A charity is considering a fundraiser event in which donors will pay $1 to spin the wheel 3 times. Okay, so it's like a game at a carnival, right? For $1, you get to spin the wheel 3 times. Now, there's some information about the game over here, and we're being asked to find what is the expected payoff for the charity each game. So notice what it says. Expected payoff specifically for the charity. So if we're asking the expected payoff for the charity, basically how much is the charity earning each game? Now, notice what the game is, okay? For $1, you spin 3 times if you get 3 even numbers. So what would we be saying there? If each spin you get an even number, you're going to win an item worth
$4.
$4. I swear I heard
Just
something.
by your door.
Okay. Normally I notice a difference, but okay, so that's the game. Now, first of all, we need to talk about probability. Okay? Before we can really look at this. So, you guys know the basics.
3 out of 6 is even.
So, just in general, we'll do some side work here. Probability of spinning an even number is
3 out of 6.
3 out of 6. And 3 out of 6 is 1/2 or 0.5, correct? Okay. Now, we've got to go a little farther with that, because what's the game? 3 even numbers. So now let's talk about what's the probability of spinning 3 even numbers. Now, think about it. That's 3 spins, right? What's the probability of getting an even number on the first spin?
3 out of 6.
3 out of 6, or could I go ahead and reduce and say 1/2? That's the first spin. What's the probability you get an even number on the second spin?
2 out of 5. Wait, no. 1 out of 5. No.
No? Help her out. What's the probability you get an even number when you spin the second time?
6. Something out of 6.
Does anything change on the spinner?
3 out of 6.
It's still 3 out of 6 or 1/2. So the first spin, you have a 1/2 chance of getting an even number. The second spin, you have a 1/2 chance of getting an even number. What about the third spin? You still have a 1/2 chance, right? It's a spinner, so it's independent. 1/2 times 1/2 times 1/2 is
1.
1 times 1 times 1 over
6.
2 times 2 times 2. 8.
Huh?
2 times 2 is 4. Times 2 is
Ooh.
8. Okay. Now, we have to have that information to be able to complete this problem. Okay? We have to know that the probability of spinning 3 even numbers. Because basically, what's the probability that you're going to win this game? 1/8, right? That's the probability you're going to win this game and you're going to win that $4 prize. What's the chance the charity's going to come out ahead here? If you have a 1 out of 8 chance of winning, then that means how much of a chance of losing do you have? You have 7 out of 8 chances of losing, yes? And in those 7 out of 8 chances, if you lose, what's the charity essentially do? They're kind of winning in a way because they're gaining your money. Does that make sense? Am I?
Is this a gambling situation?
It is a fundraising event for charity.
Okay.
Could we call it you're gambling $1 to see if you could come out ahead? We could, but it's a fundraising event for charity. You get my drift. Okay? Okay, so let's look at some probability here.
My addiction's too bad. I don't know what you're doing.
What is the probability of us winning a $4 prize? Okay, so I'm going to write this out. Probability of us, we're the donor because we're donating our money. Probability of donor winning the $4 prize. Okay, I'm just trying to get information down here. So how do we win a $4 prize? If we spin what?
So even.
The 3 evens. What's the chance we're going to spin 3 evens?
1/8.
1/8. This is kind of what I just talked about, right? So basically, the probability that we're going to come out, we're going to win $4 is 1/8. Now, what is probability, gosh, I all of a sudden couldn't spell, of, how do I want to say this? The donor not winning.
7/8.
Okay, that's what we already talked about, right? The 7/8. So the donor not winning having serious spelling issues. And it's the idea of 1 minus the 1/8, which is 7/8, right? 1/8 chance you win, then the other 7/8 chance you lose. Okay. Let's talk about the charity here. I'm just thinking about how I want to set this up. Because what are we being asked for? The payoff for the charity in this time, right? So, what are the options? The charity could earn $1 off of you, yes? And what is the chance the charity is going to earn $1 off of you? I'm going to say the probability they earn $1. When does the charity earn $1?
And you lose.
When you lose. Fair enough? So probability the charity earns $1 is 7/8, because there's a 7/8 chance you're going to lose. This game is not in your favor. Okay? Now, what's the other option? The charity could earn $1, or what happens when you win? Kind of lose $4. Do you really come out $4 ahead?
No.
Why do you not come out $4 ahead? What do you have to do to play this game?
$1.
You have to pay $1. So how much are you really coming out ahead?
3.
You're coming out $3 ahead, right? So with that in mind, they could lose $3, right? Because the idea of you paid $1, or they got your $1, but then they had to give you a $4 prize, right? Does that make sense? So what's the chance that they're going to lose $3 on you? Well, that's the chance that you're going to win, which is 1/8. Now, what I'm trying to do here, because this is a tough one to think about through our first time, is I'm trying to get the information written down so we can find the expected payoff. Because that's what I want to do right here. Is I want to find the expected payoff. And this is the expected payoff for the charity. The charity could earn $1, and the chances of that happening? 7/8. So I'm going to say $1 times, what's the probability it will happen? 7/8. Plus, what else could the charity do? They could lose $3. What's lose $3? That's a -3. What's the chance they lose $3? That is a 1/8. Find your expected payoff. Now, you can go to the calculator, or I left you with fractions. It's not too bad. What is 1 times 7/8? 7/8, right? Because 1 times everything is just itself. So 7/8 plus, okay, what's a negative times a positive?
Negative.
A negative. What about 3 times 1/8? Think about it as 3/1 times 1/8. That's going to be what? 3 times 1 over 8 is going to be 3/8. What is 7/8 minus 3/8?
4 over 8.
4/8, 1/2, or how much money?
5/5.
50 cents.
Oh, yeah, right. You.
0.5, right?
Yeah.
So 0.50, so 50 cents. Now, what are we saying here? On average, every time you play the game, the charity's going to essentially earn 50 cents off of you. That's the expected payoff. Or, expected payoff for the charity. Now, what is the expected payoff for the person making the donation? Realize we're just going to reverse the pieces here. Because if we're talking about you, me, we have a 7/8 chance that we're going to what? Lose $1. And we have a 1/8 chance that we're going to win, which is winning how much overall? $3. And so you end up with the negative 7/8 plus 3/8, which is negative 4/8 or negative 50 cents. In other words, if I keep playing that game over and over and over, I'm essentially giving them 50 cents every time, even if I win on occasion.
So you're wasting your money. So never
You're
play-
donating to charity. That's the cause, right? You're donating to charity. The chances are not high you'll win, so overall, it's a donation. And you get to play a fun game, right? That's the idea. Okay, we will talk about this subject more tomorrow. Okay? We'll work on it. I know this one was a little bit confusing, but we'll continue working on these tomorrow. 12.4 is due. I need a lot of you to get it done. Okay?